Hi, everyone. Good afternoon. My name is Mike Wu, and I'm from computer science. I joined San Jose State, I think, 4 years. I from I moved from Michigan. I used to teach at the Michigan Oakland University. It's a research university, and then I went back to moved to the Bay Area. I worked for industry for several years, and then I come back to academia to teach. First of all, I introduce my course, my course background I use for the specification gradings. The class I teach and apply to specification grading system is the design implementation of database management system. So this is kind of the student learn how to design and implementations of the using the commercial database, right? So they involve a lot of the several course objectives, right? So in this class, I have 30 undergraduate students, and is during the fall semester 2021, and that time is still online, all right? And if you look at the course objectives, and then we kind of direct this to the course learning outcome. Right. So basically, this class I teach students, they introduce to students what's the purpose of the different kind of database management system, and basically this is kind of we focus on relational database. We have three level of the database system for undergraduate student. First is 157A, which is this one. It's learning the different database system and then how to design it. But we focus on relational database. Relational means that making the tables and make a relationship between tables. So most of the database application, they use this kind of the relational database. And second level is we look into the database management system, just like the operating system for the computer. Right. And the third level, I'm teaching this semester, CS157C. So it's a NoSQL database. And they are very similar course, but the different level of from introduction to advanced development of the database system. Okay. And so they involve the first step, which is kind of my lecture and also the student from my lecture first, and then they apply the knowledge, the skill they learn from my lecture and go to the design phase, and then the design database, and then do the implementation. So in this class, we have the big portion, big component for the student team project. So it's going on for like one semester. So we start with the design theory. Okay, it's just like a normalization, how to kind of normalize a back when you design comes the back table and into the good tables, right? So when you're trying to delete, you're trying to add, remove those the data is so you are not going to lose any data that you store in the database, all right? So we also teach the real world database system, architecture component of the database system, and then we use one of the popular commercial or open source the database management system. Okay, so in this class we use the MySQL. It's open source, yeah. And then we teach the student how to do the programming. Okay, how to kind of create CIUD, create, update, delete, and kind of to access those the access to the data stored in the database using the SQL programming language, and then student have to learn it, and then because this is the high division course, student the prereqs of this class is student have to learn data structure and algorithm. So they must have the capability to using Java to write data structure and algorithm. So in this class, you already know how to do the programming. So they have to use the programming language and then embedded the SQL language to the Java. All right, and of course that we The project we focus on industry oriented. I adopt the Google's because I am also the Google record faculty in residency for San Jose State. And then I used adapt those the Google, how Google developed the software system project. So I use that and go through the step by step for students to develop database application, okay, step by step. So this is the about my course and the course objectives. So we direct the course objective, and that's before that. Okay, so this is traditional approach. I have been teaching the university and back and forth between industry and the university. I also teach the Air Force Academy and also some other university. And that's the traditional approach I use all the time. Class participation, you show up, you take part quiz, 10%, homework assignment 25%. So this traditional approach has been used this for a long time until I joined this cohort, and I learned that specification grading system is much better than the traditional, right? So in this course, I kind of progressively adopt the new approach and then updates on this old approach. Okay, using this approach, my teaching evaluation is so bad. Dr. Wu is so strict and he's not a fair grader. So a lot of professor and instructor, they have the same kind of feelings. And when you look at the readmyprofessor.com, you will see, okay, student want that response. And so I move. Okay, so this is the traditional and universal digital number grading distribution. When you come up with the number, so I give you A and give A minus, and the result I need to do. So I always reject student kind of summation by email or anything. It's 0. Okay, 10-9, and you pass the 10-9, you did not submit it. The only thing you got is 0, and the result I need to do. So after I adopt it, so I'm also a member of the ABET assessment committee. So I have been this for like from other university to this university. I have been doing this for several years, and I still cannot find a way that when you teach the course and it kind of perfectly match to your course learning outcome. And then I got it, right? So specification grading system is really cool to me, right? So we have 9 course learning outcome for students for this course, starting from theoretical knowledge, practical skill, and then entity relational, that's part of design, and up to SQL programming language, and then to the application program project. Okay, and then I turn this into specifications, matrix design for CLO. So for each CLO, so progressively from outcome 1, outcome 2, I assign the percentage for each one. Of course, the 9 is the project. So the projects occupy 20%. And then I have the 2 homework, 5 homework. And the homework cover the object, the learning objects 1 and 2. 1 and 2 and 3. Homework number 3 cover the learning outcomes 4 and 5, and homework 4 covers the outcome 6 and 7, and so on and so forth, right? And in terms of project, so we have design, coding, demo, and the report, final report. So each one occupies the certain percentage in terms of the category of the learning outcome, all right? And I had the participation. So participation is kind of pop question for students. I have pop quiz, right? So the total for a semester, I have 8 pop quiz. And then participation question, there's a lot of participation, these pop questions for students during the class. Okay, so so each student that kind of be in the class alert that, Dr. is going to give us the pop quiz or pop question. So no one sleep, and they kind of engage a lot to my lectures. right? So this is the distribution in terms of assign the percentage of the to each course outcome, right? And then I create the rubrics using the specification grading approach, and what based on this the course learning outcome. All right, so we have the class participation. For A, you have to answer 50 pop questions. If you only answer 12 pop questions, you got B. You own 10, you got C, you got 8. So students have kind of overview, okay, what's the status of his learning, right? And I have a plus and minus and so on and so forth. And quizzes, okay, if you passing a score on the learning objective, okay, for in terms of the quizzes from here, and then you assign the A and B and C, all right? So I no longer use those, okay, participation 15% and the midterm 25%, something like that, right? So 3 exams, all right, you average in terms of this, and then, okay, 90 something, and then you got A, B, C, C, and D, okay, and project. Okay, and so on and so forth. So that's the approach I use. Start from the course learning outcome, and then rubrics for each outcome in terms of the coursework. All right. So the result, yeah, after using this approach, I have a lot of improvement on my course evaluation. Yeah, so now my class is booked up very quickly. All right, so now yesterday they opened it, and now it's about 20 students in the waiting list. Right, so positive response from the student course evaluations. That's one of the things that have helped from the specification grading system, and it also it make the grading more transparent for students, right? So when you try to the student try to do this homework, he already have the preview of, okay, what's the grade, how much the satisfied the learning outcome. And you know that, okay, this homework is for outcome 1, outcome 2, something like that. And normal complaints from student, right? So in the traditional approach, when I give return the homework to student, they always want to make an appointment with me. Okay, I want to fight for my point, something like that. Okay, but this is the very specific and very clear. So normal complaints from student about ambiguous, unfair gradings. And they also give a student very clear picture of the what they're going to learn, and how much you need to improve to get an A or get a B, or you are in the failing, okay? So give the student also early warning message, okay, you are failing because that you miss a lot of the outcome, the learning outcome. You did not, if you learn it perfectly, you got A, maybe A plus. And I also allow students to redo using the specification grading system, but you want to redo, okay, but I did not use the token system. I just, if you redo and I give you a minor, okay, penalty. Okay, a lot of students, they had multiple class to take. Sometimes they have the catch the multiple denies. So let them redo, they really appreciate it. And they also help them to improve their learning. Okay, all right, and take away, right? So using this, using the Google Color. So the number of the learning outcome they earned determine the student's grade. All right, so students are learning, okay, what's the things they want to learn. So using this approach, we allow students to know exactly, okay, how many outcomes you have to achieve to get a grade they want. And also students must kind of master all the course learning objective in order to pass the class, okay? So using this specification in the beginning of semester, when I introduced the course syllabus, students kind of focus on what's the learning outcome and what's the course learning objects. They pay attention to that. Using a traditional approach, they don't care. They just want to get a good grade. And yeah, no matter this professor is top, is nice, give me a good grade, right? So they don't care what, and they are not going to pay attention what the things that they're going to learn. So this is great. I really, to me, this is very beneficial in teaching. And students get a multiple chance to pass each the course learning outcome. Okay, that's in the sense that specification grading is more closely resemble and how things they learn and assemble throughout their life. You want to reach your goal, you have to go for it. Okay, and how much effort you have made, and that's what you're going to receive. Okay, no pain, no gain. right? So the approach makes more sense for the ABEX because I'm has been doing ABEX, and this approach is really good when we have the ABEX assessments and for each year. And summer course is 2 years, 1 to 2 years, and it's kind of save our time. We know what's the learning outcome, and in terms of homework, and in terms of the pub quiz project, and this really, they really help improve my teaching. Okay, thank you so much.